Okay. You might have yours?
Yeah. I'll look later.
Yeah, look.
Later. I'll do this now.
Why? I mean, what?
I have like literally like 4 unpacked. I'm so
Very Mr. Staley, I have my CA for
Nice.
I don't know if now you're set on that.
Oh. All right. It's okay. I won't look. You look. Use basic identities to simplify the expression. Okay. What can we put in here for cotangent theta?
Sine over cosine.
Cosine over sine. How about secant? What are we going to put in there for secant? 1 over cosine. And then, of course, we have the last but not least, plain old sine theta. Anything cancel out? The cosines and the sines. Wow, that was nice. All right. So, let's see here. What can we do with cosecant? 1 over sine. And they cancel out, right? Okay, so if they cancel out, what does that become? What does this thing become? That's a 1, right? So we got that part. What's this part? It is not tangent squared, but you're really close. Cotangent squared. Now, is there one of those cool trig identities that equals?
Yeah, we did the formula sheet on the test.
Oh no, we won't give you any formulas. Whole semester's worth, and we're not going to give you any.
Like these kind of formulas.
Of course you will. Yeah, it's one of the cousins, isn't it? Like, so we got, wow, I can't write. Cosine squared theta plus sine squared theta equals 1. Sorry, I'm squeezing this in here, but if you want cotangent, then you better divide this by sine squared. Okay, which means I would divide that by sine squared, and I would divide that by sine squared, and man, I don't have enough room. So, that's cotangent squared plus 1 equals what? What is 1 over sine squared? Cosecant squared theta. That's what you would find on your multiple choice answer. Okay? Go ahead and ask. Where did I lose you? Where did cosecant squared come from? I mean, are you? Was it just the Pythagorean identity over there on the left side that kind of confused you?
No, I went down to write something and looked back up and it was done.
Okay.
So I'm trying to
Okay.
what happened after.
So we did a substitution here, which caused me to be reduce that. That's the one over here.
Okay.
Then we looked at this, and this was cotangent squared.
Okay.
And then we went back to our Pythagorean identity and realized that if you divide that whole thing by sine squared theta, you end up with cosecant squared theta. Okay. What can we replace this with? Tangent pi over 2 minus x. That is the cotangent of x. So we have the cotangent of x times the tangent of x. Now, they were nice enough to tell you that the answer was either 1 or negative 1. Any stabs in the dark? Which one do you think it is? Probably a positive one, right? Because you'd have your cosine over sine for the first one. And then you'd have your sine over cosine for the other one. So.
Why don't you just do 1 over tangent x times...
And yes, that's another way to do it. Hey, I like that. 1 over tangent x.
Cotangent is 1 over tangent.
Yes, that's another good way to look at it. Yep, they cancel out. Nice. I like it. All right, what are we going to do with this one? Man, we need a formula sheet, don't we? Okay, let me see if I can quick think through this. Let's see. If this is x, this would be pi over 2 minus x. So the cosecant of that one, cosecant would be hypotenuse over opposite, right? So hypotenuse over opposite. Hypotenuse over opposite. That would be the same thing as the sine of x. No. It would be hypotenuse over opposite. Hypotenuse over opposite. How would that relate to x? Okay, what did you say it was? Secant? See if that makes sense in my mind. Secant of x. Secant would be, let's see, that's the Shah. Hypotenuse over adjacent. Oh, yeah, because that would be hypotenuse over opposite. Yes, that would be. You switch to the other one. Yep, that's right. Nicely done. Okay, now.
So is that in the formula sheet, or do we just have to know it?
Of course it's on the formula sheet.
Are you reading
No. There's no way I'm gonna give you. I mean, I wouldn't give you a chapter test without these things, let alone a final exam. I mean, that would be insane. Why was I doing it in my head? Because I didn't have the piece of paper in front of me. So I was trying to rationalize it through the triangle, which is where the proof comes from anyway. Oh, we would have a formula sheet. You know, like the one you have in front of you. Okay, now, I need to understand or remember what you think we can do with this. Okay, if we pull that negative out, the question is, do you remember if cosine is an even function or an odd function? Because if it's an even function, that negative comes out and disappears forever. If it's an odd, then it would stay on the outside. What do you think? This is an even function, therefore it comes out and disappears forever. How do I know that? Because we studied the cosine function, and the cosine wave looks like this, right? And an even function means that it's reflection symmetric across the y-axis. You can fold it on the y-axis and it looks the same. So what they're getting at is this. If you take some value over here, let's say at a positive x value, and then you switch to a negative x value over here, you would get the exact same value.
Okay, so cosine is even?
Cosine is even. Sine and tangent are the oddballs.
So then the opposite of cosine would also be even?
The opposite of cosine? Yes, secant would be correct. The reciprocal trig functions have the same even and oddness. Okay, so what do you get when you take secant times cosine? You do get positive 1. That's true. Right? It's 1 over cosine times cosine. Okay, 27. Oh, let's see.
Well, what is the top part equal?
Yeah, the top part equals 1. All right. So, I don't know why it seems too easy. That seems like a trap. You know, I'm looking at that going, wow, that's just a 1. Okay, so what are we going to do here on the bottom here?
You do cosine over sine.
Oh.
Minus the 1 over sine squared x.
Say that again. What are you going to replace? Which one are you replacing? Are you going to replace cotangent squared or cosecant squared? Which one would you like? I don't care.
It doesn't matter.
No, it really doesn't. Okay, if you're going to replace the cotangent, what are you going to replace it with? A little bit ago, we looked at this Pythagorean identity. All right, and it was cotangent squared. Okay, plus 1 equals cosecant squared. Okay, so take your pick. If you decide you're going to replace cotangent squared, what are you going to replace it with? Cosecant squared minus 1. Okay. So cosecant squared minus 1 minus cosecant squared. Does anything cancel out on the bottom? Because one's positive, one negative. What's the answer? Negative 1, right. I can't get rid of this, man. Remember, they're multiple choice, so the answer will be there. But no, they shouldn't all equal 1 or negative 1. Okay, let's see. What do we want to do here? I feel a difference of perfect squares coming on here. How about a tan x minus 1 or plus 1? We'll do the same thing to the top. I don't know, this... So let's see. That top looks like a mess. And not a hot one either. 10x. Oh, it's not too bad, is it? So 10x, I'm doing the FOIL here. What about my, oops, what in the world? Nope, don't need that. I'm like, what the heck? I don't need to see my face. Randomness in the video. All these people from these other classes are going to see. Never mind. Okay, so we're foiling this thing. Obviously, 1 times tan x is pretty easy. 1 times 1 is easy. Okay, what about negative cotangent times tangent? Think about it. Negative 1, thank you very much. Yeah, good call. And then negative cotangent times 1 is negative cotangent x. Okay, folks, this stuff in the middle disappeared on me. And then I got tan squared minus 1 on the bottom. How is this looking better? Oh, no, this is the wrong way to go. I remember this one. This isn't going to help us. Well, we could get there, but I'm afraid there's a better way.
Can't you cross out?
Can't you just what?
Well, couldn't you take in the tan x above and taking the tan x squared down to just a tan x, and then you would have taken the cotangent as 1 over tan. Hold on. Never mind.
Yeah, I did work this one out earlier, and I do remember this one. I would not expect to see the depth of this problem on the final. Okay? Okay, but let's replace cotangent x with cosine x over sine x. Okay? And tangent x with what? Okay? So while I like this problem, I just think this is too involved for a final exam question. But, the parts of it are important. Okay? If just like everything in your Algebra 2 days, when you had complex fractions like this, you found a common denominator and you multiplied the whole thing. What is the common denominator here? It's not a fraction, folks. It's just sine x times cosine x. Now, just to kind of, remind you of something, what if this problem said 1 minus 2/3 over 4/5 minus 1? what would be the common denominator there? You'd probably say 15 because 3 and 5 have nothing in common, so you would multiply them together. That's old Algebra 2 stuff. Okay? But the same kind of idea holds true, that if they have nothing in common, you're forced to multiply them together. Okay? So if you multiply the top and the bottom by sine x cosine x, what happens? So what happens when we take it times the 1? We just get sine x cosine x. And I'm going to try really hard not to mess this up. Sine x cosine x. And then what happens when I take it and multiply it times that fraction? What cancels out? The signs cancel out, leaving me minus cosine squared. Right? This sign and that sign cancel, leaving me minus cosine squared. Okay? So now we're going to do this on the bottom. We're going to take this times that fraction. Anything cancel out? The cosines do, leaving me sine squared, right? Right? And then what happens when I take this times negative 1? Negative sine x cosine x. Like I said, folks, the logic that's going into this question is fantastic. Putting it all in one problem is not going to be realistic. Okay, now, hold on to your thoughts. There is some canceling going to happen here. What can you pull out of the top? You can pull out a cosine, right? Man, I'm running out of room here. Okay? And what will be left after you pull a cosine x out of the top? Sine x minus cosine x. Okay, now what can you pull out of the bottom? A sine x. Which will leave you with sine x minus cosine x. Now do you see anything that cancels? Sine x minus cosine x cancels. Leaving you what? Don't you read it out loud. Think about it. Oh, good job. Cotangent. Okay? Now, all those parts are great. Together in one question, not so much. All right? We don't want to burn up 5 minutes on one question on a test. Too much. Okay? That's why these kind of proofs have to be more simple, or simplistic, I should say. Well, we're not multiplying. If we were multiplying, the answer would be yes. We need common denominators. So, this one's missing a 1 minus sine x. Top and bottom, right? And what's this one missing? Cosine x. Okay, so what do you have in that numerator right there? Cosine squared. Okay, and then if you FOIL the numerator on the other one, what do you get? We get a 1 minus a 2 sine x and a plus sine squared x, don't we? All over what? Cosine x times 1 minus sine x, because then we have a common denominator. Okay. I'm going to circle two things, and I want you to tell me what they add up to. There's 1 right there. In the numerator, you should be looking at that going, oh, there's a 1. Right? Now, if I add that 1 to this one, how many does that make? 2. So, I know that's going to look like magic if you don't watch this video. Alright, but that's what's going on. And then, of course, we have minus 2 sine x. All over cosine x times 1 minus sine x. Is there anything you can pull out of the top? Pull out a 2.
Hey, can you explain how you got that?
Okay. Which part?
The numerator, 2 minus 2.
Okay, so see the parts in the red that I circled, the cosine squared and the sine squared? That's together, using the Pythagorean identity, that's 1. But then if I add it to the one that I see already sitting there, that's where that 2 came from. Okay, so if I pull out a 2, what am I left with? 1 minus sine x. Cosine x, 1 minus sine x. Do I see anything that's going to be canceling? Yep, the 1 minus sine x is. And what's the final answer? 2 over cosine x. Can we say that a different way? 2 secant x. It's beautiful. Yeah, when you do these right, they're nice. When you don't do them right, they're ugly. Folks, remember, we can't take 5 minutes on an individual question, so we have to have nice, simple things. Some of these, stretch your brain a little bit more, right? So I wouldn't expect, a difficult proof. Besides, it's multiple choice, Now, the proofs are the ones where you are given the beginning and the end. I doubt you'll see one that says, prove this. Like, how do we do that in a multiple choice, Here's 16 steps on letter A. And you have to go through and make sure every step is correct. No. So we might ask individual steps, but not, giant ones. Okay, do these have the same denominator? Nice. So we can combine them together. Secant x minus cosine x over sine x. All right, is there anything we can do with that? Well, yeah, we could do secant x equals 1 over cosine, but then I'm still...
Could you put 1 over cosine on the bottom?
Ooh.
Cosine.
So...
And then have, 1 minus cosine x over cosine sine x.
What if... All right, I'm just thinking out loud here. I think I'm going along the same lines you are a little bit. What happens if I multiply this by cosine x? Now, I'm not saying this is gonna, because I was trying to do what you're thinking. All right, so some of you have already told me that secant x is 1 over cosine. So just keep that in your mind. So when we distribute that to that, what do we get?
1.
We get 1, right? And then when we distribute the cosine x to the minus cosine x, we get minus what? Thank you. And she's not here. No. She ran away, evidently, after the meet last night. Cosine x times minus cosine x. Do you need somebody? Sure. Okay. Still don't know what cosine times minus cosine is.
Do you just want to keep it for tomorrow?
Do I want to keep it for tomorrow? Well, no guarantee she gets it, but oh well.
Oh, okay. Miss Swing, if you're listening to the video, I've got some envelope for you. It's on my
My
desk.
future self, that's not going to study.
What? Okay, I didn't. Well, we know. Never mind. All right. And on the bottom, we got cosine x and sine x. And there's not a whole lot you can do with that, folks. At least in the denominator. What about the numerator? What is that? Let's think about it. Is it sine squared x? Okay, so I'm just going to, over here on the side, sine squared x plus cosine squared x. And the reason I'm doing this is because I don't want to screw this up. Is it going to be negative sine squared or positive sine squared? You tell me. If I put the cosine squared on the other side, will I have sine squared or negative sine squared? It is positive sine squared. I just didn't want to make that mistake because we've done that in the past. We've made that mistake. And we ended up not getting the correct sign. Pun intended. Anything cancel out? One of them does. We got a tangent x. It's beautiful. Whew. Man, this is good stuff.
Yeah.
A lot of notes?
Yeah.
Good. Trust me, in college they just fill the chalkboard and start over. I wonder if they've moved on from chalk.
I can't listen to someone write with chalk.
Oh, well,
I know.
I mean, some of them have whiteboards now. But I'm hoping they do more stuff like this, you
It
know.
makes me crazy.
Yeah? I actually wanted to try to find an app, where as I write, it makes the sound of a chalkboard, as...
Drop out of it.
Yes, you would. Yes, you would. Write each expression in factored form as an algebraic expression of a single trigonometric function. Okay? Cosecant squared x minus 1. I'm guessing it has something to do with... Oops, that's not what I wanted. How do I get cosecant squared out of this trigonometric identity over here? Cosecant squared is 1 over what? Sine squared. So that tells me what to do to the rest of this. Okay, now. So if I've got cosecant squared, here's 1 right here. And if I subtract that 1 to the other side, what am I left with? Cotangent squared x. That was so convenient that we had the Pythagorean identity written out for us. Some of these things just work out, folks. All right, so we got to solve. Yes? Do I need to stop? All right.
Where's the work?
I did the work over there. This wasn't very involved because they set you up with one of the cousins of the Pythagorean identity and basically said, which cousin is it equal to? So now I took my Pythagorean identity over there in the blue, and then I said, okay, how do I get cosecant squared to show up? And you said, well, that's 1 over sine squared. So I took my blue Pythagorean identity and divided everything. So I have, cosecant squared x equals cotangent squared x plus 1. And so in order to get cosecant squared x minus 1, which is what they started with, I move that 1 to the other side, and all I'm left with is cotangent squared. So you could literally probably go to the formula sheet and pick this off. Yes. Question. So, yes.
Are you going to give us the cousins to the thing?
I think I gotta look and see if they're gonna argue with me on that one, but I want you to have it.
If you want us to have it, we should have it. It's just
Oh, that's so special. Okay. I don't get to choose all the time what the team decides. I wish.
You can just not tell
I can just ignore them.
Yes. Not tell them.
That reminds me. Yes. That reminds me of some things. All right, so how do you factor this? Pull out a sine, that's right. Little GCF going on there. Pull it out, and we got a sine x plus 1 equals 0. All right. So now we set the two factors equal to 0. Sine x equals 0. And how do you solve this one? Well, yeah, we'll get to the unit circle part in a second. But
Sine x equals
sine x equals
negative.
-1. Okay. So we're looking at the unit circle and trying to come up with all of... Now, are these x values, y values, or slopes? Ooh, they're y values. That's a y value there. All right. Okay, so y value is 0. How many answers do we have from 0 to 2 pi? 2, what do you got? Well, 2 pi is not included in this interval. You will, I mean, number one, it's multiple choice. I'm pretty sure we wouldn't put 2 pi as one of the possible answers, although that would be slightly evil. All right, so 0 and pi, right, would be the answers to that part. -1, well, that happens down here. What do you got for that one? 3 pi over 2. Got to factor the next one. What does this break up into? A mess? No, folks, we know how to factor quadratics. We've done this before. Cosine x plus 1 and cosine x minus 1. Yep, been down that road before. So we got cosine x equals -1 and cosine x equals +1.
Shouldn't the second be plus 1? Yeah, on the second factor.
Oh, good call. Good call. Good catch. Thank you very much. So that means that isn't even true. Cosine x can only equal -1.
Why?
Because I factored it wrong, and they caught my mistake. The only way you can get a +1 on the end is if you had +1 times +1 or -1 times -1, and there ain't no way we're good negative because we got a +2 in the middle. So you were right. Good job.
So just be pi.
-1, and it is an x value. Nice. Pi. You and I watched that movie, The Life of Pi. I thought there'd be a lot more numbers
The
in
one
it.
with the tiger?
Yeah, I was really confused, and I thought to myself, I watched this whole thing.
I don't know what to begin with.
Easy, great. All right, cosine 75. No, this is no calculator.
Just check.
So I'm going to have to look at my formula sheet and decide whether I want to use a difference or sum from the cosine. Now, what would you prefer? Do you think we can take some of the nice ones from the unit circle and add them together to get 75? Okay, what would you choose?
45 and 30.
All right, 45 and 30. That's an excellent choice. So 45 and 30, right? And then, of course, we're all looking at our formula sheet because nobody remembers that stuff. Cosine, cosine, and then it switches signs. Yep, that's a switcher. Cosine is the one that switches. Sine, sine. Okay, and then, you got like radical 2 over 2 and cosine of 30. What's cosine of 30? Isn't that radical 3 over 2? Folks, you're just talking about these places on the circle, and you're thinking about the x's and the y's that go with these things. Radical 2 over 2 and 1/2. So, looks like I'm really running out of room here. Radical 6 over 4 minus radical 2 over 4. And it's multiple choice, so look for the answer that matches. If it's all combined into one fraction, radical 6 minus radical 2 all over 4, I'm sure you'll find it. Okay? Okay. What about, let's do a subtraction one for 105. Let's just see, can we think of a subtraction one? I mean, I know 105, you're probably going to think 60, 45, and you'll add them together. It's no big deal if you do it that way. I mean, that works too. Yeah, we could. Okay, but I wanted you to think subtraction just for a second. Is there anything we can come up with?
We do 150 minus.
Was there 135
150 minus 45? Yeah, that would work. All right.
What I said?
I don't know. What'd you say?
135 minus 30.
135 minus 30. Hey, that would work too. Nice job. Okay.
I don't even know what 150 is.
150 is one of the nice ones that we use, right, on the unit circle. So it's 45. Those are the
It's not a common one.
150 is, yeah, it's right over here.
Well, it's a common one. It's not one that's used often.
It's not in quadrant 1, if that's what you're getting at. I do understand that, but we should all know the x and y and the slope of that one. So sine, according to my formula sheet, goes sine 150. So sine cosine. It keeps the same sign, so that would be minus cosine sine. So yes, you need to pay attention to your formula sheet. And I don't care if you decided to go with 60 plus 45. You still need to pay attention to your formula sheet.
So or 1/2.
The y value at 150 is 1/2. Good.
And then
The x value at 45? Radical 2 over 2, right? What about the x value at 150?
radical 2 over 2.
Negative radical 3 over 2.
And then radical 2.
And then radical 2 over 2. So we end up getting radical 2 over 4. And then what? Is that right? Is it a plus?
Yes.
If you think a negative times a negative is a positive, then you better say yes. Thank you. Radical 6 over 4. That is some cool stuff. All right, what's next? Do we have any more on that? Oh, yeah. Okay, these are actually easier because they want you to identify whether it's sine or cosine, and you're either going to be subtracting 88 and 26 or adding 88 and 26. So which one? You'd look at your formula sheet, the one that goes sine, cosine, cosine, sine, that's a sine. Okay? And since sine stays the same, it's a minus. We want 88 minus 26. So the answer that you'll be choosing is sine what? 62. Okay? How about the next one? Cosine, cosine, sine, sine. So that's a cosine. All right? And then it changes signs, right? So we want pi over 2 minus pi over 5.
Negative pi over 3.
Let's think through that for a second. Let's get common denominators. So that'd be 5 pi over 10 minus 2 pi over 10. So that'd be cosine of 3 pi over 10. We'll keep recording tomorrow.